at least in this room, oh, not again, there seems to be periodic radio interference. And so if you, the last two lectures, halfway through the lecture, it became a nice big nah. So I don't know what it is about this building. So I'll try and talk louder so the microphone will pick it up. Second announcement is 2 days ago, Pandas went from version 0.2 something, like 2.5, to 1.0. So you may want to, if you've installed Python and Pandas, you may want to update your Pandas. The main thing they did is there were a lot of things in 2.5 that were deprecated, and they all went away. So they removed a lot of deprecation. So if you're just learning Pandas, you should start with 1.0 because then you don't learn. You're using the deprecated stuff, which 6 months now you can't use anyway. Updating software is always fun. Well, the good news is going from 0 point something to 1.0 is usually not too bad. Going from 1 point something, 2 point something, things break. Which is the definition of going from 1 to 2, right? That's the only reason they go there, and so. Any questions? You all tired from looking at project last night? What's going to happen last half of the semester then?
I don't really think about it.
Left an espresso machine in here so you can wake up. So last time we were talking about Python, so it's probably too fast for a few people and too slow for everyone else. We're almost done. Right. File I/O. There's this nice little feature called with, right? And the nice thing is, in the block of code, you do whatever you want to do with the file. When the block is done, the file is closed automatically, so you don't keep on leaving files.
Is with a keyword?
Yeah. Well, yeah, in Python. Yeah. And we can read the whole thing. We can read it by, ask for lines in the file. We can read it line by line, read lines, various ways. And we'll. And we got exceptions. And then you can raise exceptions with arrays. And there's also finally, so there's fairly similar to what you do in Java. And we won't do too much of this, but we can create classes, right? For those of you who haven't dealt with Python, this is where you start getting to be careful, right? Well, because, this is a class variable, it's not an instance variable, right? And here's how you create instance variables. You just say the value equals this, right? And so then I can create a dog. At least I didn't do the new thing. Just, right. And then I get the name, I can sign the name, and then I can do this. which is both good and bad. It's good because there are times when you want a particular object to have more things. The bad thing is if that's a typo, you don't know, right? Yeah. The compiler's not going to help you. The runtime's not going to help you. It's just, you said you wanted a size equal to large, so okay, we're done.
Just to be sure I get this right, the dot size could be confused with the function dot size, like how.
Well, this is just what I'm doing here is I'm just defining a new instance variable or new field, right? And basically, we can consider a class even in Java. The field, the properties are just a dictionary, right? They're mapping a name to a value, right? And in Python, that's pretty literal. That's just the key into basically a dictionary to get values out. And so you're just creating another key, right, in a dictionary and assigning a value to it. I mean, there was a time in software engineering, an academic could say, a dynamic language like this could never work for this reason, right? You know, you'll just create too many bugs and never going to be able to build large-scale software using a dynamic language. And they know that, you know, half the planet is glued together with Python code. And then we get it back out. And then I can create a function and assign it equal, you know. I mean, what's a method, right? Again, it's just a mapping between a name and a function, and so we can just add it to the dictionary, and then we can call it. So something you just can't. I mean.
So, since size isn't defined in our class, is it still going to be, like if we had another dog instance, would size still be there?
No. So the question is, if I create a second dog instance, will it have size? No.
Okay.
You added to the dictionary of that particular dog. You added speak to that particular dog. Right?
Use like class dog object anymore?
What's that?
Like class and dog open the object in the button to dog object.
So I get a green.
So for class, we usually declare like the name of class and we have the object. It works.
In Python? You also just say class dog, right? So that's a brief introduction to and let's see, did I pick it up? Now we'll start talking about Panda data structures. So Panda is just a very common library in the Python world, particularly in analytics. And so there's a number of data structures. One is a series, and every system that you use to do data science has data frames. You know, the Python, R, MATLAB, Julia, and Spark has. And a data frame is just a two-dimensional table, but it can have column names, column labels, and another difference between a two-dimensional matrix and a data frame is that each column can have different data types in it, as opposed to if I create an array, two-dimensional array, then everything has to be the same type, right? And basically they use it to do a lot of SQL-like queries on the data. And so data frames basically become, well, like a SQL database, but then we have to create a little language to query it. So instead of using SQL, we're going to use what they created for us. And then on Spark, they realized, well, people want to use SQL, so they embedded it. There's a library to convert SQL queries down to DataFrame queries, so you can just use DataFrames. Let's see how this goes. Why are you starting the very beginning? And so I'm using Jupyter Notebook, and we'll see how this goes. I'm using a system called Rise, which allows you to create slides on a notebook. And I need pandas and NumPy, so I import them and importing abbreviations. I don't like abbreviations, but these are pretty standard everywhere. I see them a lot. Yeah. Right, so to create a series is basically a series, and then the data, and the data can be a dictionary, an array, or a scalar. And so here's an example of creating a series out of a constant, and I want 3 indexes A, B, and C, and so they all have the same value. So here I'm creating a random array of 3 values, giving the index A, B, and C, and that's what we get. And of course, I can use any index I want, right? So it doesn't. And then I create a dictionary, right? Regular Python dictionary, and create a series of that, and then the keywords become the indexes into the values. And then I can reorder it, right? So which order I want things, and if I add extra values, there's no D in the dictionary, and D becomes infamous unknown value, not a number. Now will become a fun time because either the value is not going to be known or be blank, right? And then you have to figure out what to do about that. And on something this size, it's, okay, but what happens when it's 50 megabytes of data? You no longer can do it visually. You have to find them all programmatically and deal with accessing the elements. We can just index it, right? We can, assign the values. We can also use dict. We can ask, give me what indexes you know about. We can query for the data type that's inside there. And we can, what happens when we ask for, out of range? It depends upon how you do it. So if we just say get, it just doesn't complain. When you use the array index, and then it does complain. So either you get an exception or you have to check to see what the value you got, right? Get, we can also give it a default value. So if it's not there, then that's what you could get, which is very nice, because then you can give either a default value, which makes sense, or a value which you can check to say, okay, it clearly wasn't there. It's surprising how many times, many occasions this occurs where you basically have a dictionary or some sort of indexing. Is like, then you have to check, how big are you, or do you have that key? If you do, then do this. Why not just give me a default, this option, and it makes life a little easier. So here, again, just creating, giving it an index A, B, C, D. So now we can, give me the value of B. All right. And I can even give a array, right? And then I'll get the value of all those elements. Which shows what? That it's zero-based indexing. And then we can query, does something, do you have something, is B an int? And the answer is true. Right? And so the N is not asking about the data itself, but asking about the index. Another gotcha, right? Well, because now I can say, do you have this index? If the answer is yes, then I can use that index to get the value. We can create slices. So here, give me a slice from A to C. Give me all the values from C onward. You can also do it the other way around, say, give me all the values from this previous. Here I'm giving, asking for the values. Indexes, not, the location values, not the given indexes. Here I'm taking that slice and assigning that slice to all the values, and that leaves 0. So it's, there's a bunch of standard, list of them instead of a slice. So we have, define it, assigning the slice based upon the location, not the index. So basically, it's ordering indexes on characters, right? So it's smart enough to.
Character to the previous language.
So here we're looking at location based upon not the label or index. So that's the difference, right? So here we're give me the element in the first location, which is a 0, right? Here we're saying, give me the slice starting at the index of A down to the index of C. All right, so we can either do it by slicing the index or giving it the location. Before it was just slices, that made sense, right? What we're saying here is, like, if you don't think about it too much, it seems to make sense. If you think about it harder, it's like, what are you doing? If you're saying ints greater than 3, then after the ints, right? So basically I've created a little language, right, that we can put in, in this bracket to do some queries. And one is, I can ask for values greater than or less than or equal to, right?
Does the size of ints and index have to be equal? In the sense that there has to be 1-to-1 ratio? Or
Up here?
Yeah. What if one of them is not? Would it do an error?
I know that we've got more indices than indices that will fill them in. Good question. What happens? So what happens if we do that, right? Now to evaluate this, I'm going to have to come here and then do this. I'm in the right spot. Now, so let's come on. That's because it's wrong editor. There's also one other announcement I forgot. One of the things I don't like about notebooks like this is when there's actually two things. One's a warning, and the other one is an irritation. The warning is when you're writing normal programs, you compile them and run them, right? And so there's a runtime state to build up, but that goes away immediately. The program stops, right? What's happening here is it's not like I run a program and it ends. There's a program running, and I'm just running more and more code, so it builds up state, right? And so you can on one cell, you can declare a variable and give it a value, and then a cell above it afterwards, you can now access that value because it's part of the state. But then when you come back and execute this notebook from top to bottom, you first use a variable, but it doesn't exist yet because you execute it the other way, right? So the warning is, and some of you will do this, you'll do that, turn it in, and what we do is you just go to the top of the notebook and say, run all. And it starts at the top, but there. Like, okay, good point. Because, we're not going to my job is not to debug your program, right? The other thing is, there's no good debugger. Right? So, things like this doesn't matter. It's one line at a time, right? But at some point, you create functions and you go wrong. It's like there's no debugger, but there's two IDEs which do have debuggers, which will run Jupyter notebooks. One is PyCharm. You can actually, in PyCharm, but you need a PyCharm Professional, which costs money unless you're a student or a faculty member. So you can get it for free. You just have to have a EDU email address. The other one is Visual Code. I tried Visual Code. I couldn't figure out how to make debugger work, so I stopped. The problem there is making sure your environments are matched. And also you have to remember to use the right keystroke for the right environment. That sounds like a running environment. Too many IDs. So yeah, right. Yeah, okay, so when this is greater than its median, so give me the median value and find all the values which are larger than that. A few slides, or
one where you ints and then brackets 0:2. So those are indices. YC.
What's that?
It doesn't include it too. 0, 1, 2, yeah. Well, I think because
no, that's when you slice by the location, it doesn't include the last number.
Nope.
Which is so weird. You think they would be the same across, both
Right.
of those.
Yeah.
No. Consistency. Remember, this is an open source project.
I'm still confused. What?
If you have 0, 2, just does 0 and 1.
Yeah, so
it's
the
a
question
down,
is,
but doesn't include the last.
why isn't C,
I
right?
see. Okay.
Because
That's stupid.
All
Alright, we're good. Alright. That's what I needed.
Yeah.
One of my professors once said that the last number, like when you're slicing by location, is how many objects it's going, like after the first index. So it's not actually going like 0 through 2. You're going two objects past 0. Confusing.
Yeah. Why would you ever do that?
Well.
So now,
So this is where you start.
and then two objects.
No,
So
just
wow.
one. It's up to that,
So it's not the number,
not the number.
right?
Yeah.
Because if there was how many elements you're going to zero out, you should read the zero out. So of course, this could have been first, right? And then they added this, but there's no way to use that semantics for character. Right?
I'm just never going to use that. At all costs.
It's quite useful actually.
Huh?
When it
I'm
works.
going to use
So yeah, we can do various median. So the way this is working is this expression, right, returns a Boolean series. Right. You're basically saying that compute this value, find all the values in here which are greater than that, get a Boolean value, true, false, and now we can use that index into the back original. So it's not quite as mysterious, right? It's just basically and so when I can then use this to pick up elements of a series. Now you be careful, right? Because when I index using which am I getting? Right? There's two possible meanings for that. Right? So if your indexes are actually integers, then you can't use location, right? So now what's going on?
Is this related to the previous one?
Yes.
Oh, okay. That makes more sense.
That is the
Right?
Yeah, okay.
Slicing is a location, but not a.
Slicing is location, yes.
Can you do that one more time? Okay.
So right, so the indexing, when I do one, I'm going asking for the index, right?
Right.
And that's 1 is 8, right?
Yeah, that makes sense.
Right?
It's the next slide.
Now we're doing a slice. The slice is by position, not the index. Again, it makes sense. You set an index. I'm asking for a value, so give me the value at the index, right? How can you have a slice for indexes? I mean, what does it mean? Indexes can be strings, it can be almost anything. So a slice doesn't make any sense when you talk about indexes because they're arbitrary value. I mean, and they don't have to be in order, right? I've done A, B, C in order, but they don't have to be in order.
Show small.
You know, there's a value of waiting several decades and starting a new language from scratch. They can look at all the things, weird things that people. I mean, it's not like they start with all these quirks out at once, right? They built them up over time, and right. So yeah, I mean, the data one is using index, and the slice is using position. Now we can use that's what happens when you don't declare it to be a text field and declare it to be a Python field and execute everything, right? The loc says use the index, right? And so if I come down here, and now run them all below, and unfortunately it then brings me get another one soon. Where were we? Yes, here we go. And why wasn't executed? Run. I thought I said run all, right? Run all below. I said run all below here. Come on. Run all below. Okay. Right, so location we'll use index. So you can, right, this a, make you feel better now? Just don't use it. And that location uses the position. So you can avoid the whole confusion by just and yeah, there's a lot of, I mean, and there's a link there, but what I just do is I just Google SciPy, and it brings you to that web page, and then it's like, oh, pandas and NumPy and matplotlib, and I just click on that, and then the documentation, and that usually is always open there, and you're working here, because there's a lot you can do. Also, there is autocomplete on Jupyter Notebooks, so you can do and then tab, and it'll kind of autocomplete for you and give you a list. Yeah. But to show this, I need to get out of here and oops. And then I get a long list of, all right. Alright, so, and then if you know, right, you start typing and get a shorter list. So various operations, I mean, I can just add, right? And multiply all the values. You know, add two elements the same size together, multiply them. I can apply, right, a function to it and apply it element wise. So yeah, just remember I imported numpy and p, and so I'm just give me the sign function. And well, but then, so what's going on there, right, is, well, I'm computing the sign of each one, and then I can compare it, and that gives me a Boolean value that's less than or not. And then, of course, I could insert that in as an index, right, and get the values which are less than the value. Right, and then we can start doing things like, give me a random sequence, index, I want index by date. And basically started beginning of last year, and then I'm getting, right? And then I can just, all of a sudden, I can just say, plot that value. Right, so all I've done is create a series, right, random numbers, 1,000 of them, and then I index them by dates. By any series, I can just plot it by just calling plot. And then, since those values are numbers, right, I can call a function q with a sum on it, which basically, the first value, second value, the sum, the first two values, etc. And so then I can, look at how the, which all of a sudden tells us it was a random sequence, right? And so yeah, I'd expect it to be all 0, so okay, let's go here because sometimes negative, sometimes positive, but this is a big jump, so like, what's going on here? If it doesn't come down eventually, then we probably have some bias in our number generator. Of course, the question is how long does it have to be before we come to that conclusion is the problem, right? So it doesn't take you too long to get things done, right? Once you know the creating two series, right? Add them together, then, well, you know, there's B's in both of them, there's a D in both of them, and then there's missing values, so you can't make sense of it, so that gives you not a number, right? It's used to indicate there's a problem. And we can insert that if you want by, you know, np-nan and then we can assign the values and nans are sticky, they're very sticky, right? Once it becomes a nan, you do anything to it, it's still a nan. There's no way you can't add it, subtract it, or divide. I mean, it just remains a nan. So I'm going to add 1 to it. Now this is tricky. Why is it tricky? What should the mean be? Well, so the values are 8, well, no, it's 7 and 11, right? If you include the nans, what values do you get assigned to it? Why 0? That's going to bring the mean down, right? So there's 2 possible logical ways you can do it. One is you throw the nans out and compute the mean that remains. The other is you just refuse to compute the mean because you don't know what those values should be. Right? And the question is, which one should you use? It depends on the situation, right? Because if you think there's 10 elements and there are 100 elements and half of them are nan, you know, your results are not, I mean, the mean of 100 values gives you more confidence than a mean of 5 values, right?
Can you go through and find all?
Well, it depends on whether 0 makes sense or not.
Well, if 0 would make sense.
Yeah, so what you want to do is you want to find all the nans and then figure out what makes sense in your context, right? And it can make a major difference, right? So, right now half the planet is worried about this virus from China, and people are trying to use this very well-known model that you can use to predict how fast something will spread. But you need certain parameters. You need to know, if there is a carrier and they interact with, say, 100 people, what percentage of those people are going to get sick, right? You need to know that, right? That tells you how fast it's going to spread, right? And then you'd like to know what's the mortality rate. I mean, to tell you how many people are going to die, right? And the more accurate those predictors are, the more accurate your model is going to be. And so early on these days, if you only get a few data points, there's going to be high error rate. And so, if half your data is like, we don't know yet, then
You're saying is they don't really know how dangerous the coronavirus is?
currently they think that the mortality rate is about 5%. But again, that's an estimate because they don't know.
It's not like the data points.
Right. And some researchers have already predicting how fast it's going to grow, and the other guy said, I'm sorry, but we don't have enough data to really, we can plug numbers in how you want, and I get results out, but how accurate they're going to be, they don't know, right? So the calculation just drops all the nans and gets the mean, but it's that you really should know how many values you really do have. And this is, you have to figure out, finding is not that hard, but it's then deciding what should be done about it. So another series, oh yeah, what happens now when I ask for A? Well, that works because you both have two A's, right? What? So here I got even, odd, right? And I add them together, and it worked. And I just executed it, right? Right. So we can reindex, so I create it, right? When I create a series, right, a dictionary, I can now give them various different indices, right? And then I can just say, reindex it and give a new index. So if you have different values, you can just replace them. And I can, it doesn't have to be numeric reindexing too. And replacing an index, I can just assign the index to be a. And indexes don't have to be homogeneous either. So I got, a series with 3 elements. And now I can re-index it, giving it a range of 7, and so it just adds some value. But now I have the nands, and so I can give it, tell how to fill it. So fill forward means when I add a new value, take the previous value and copy it. That's why we didn't get rid of the first one, we got rid of all the other ones. And then of course there's a backfill, which is, right, takes the next one and copies it forward. And then you can just give it, fill value. Right. So far, so good. And of course, you remember all this now, right? So I could give you a quiz. Tuesday, it takes time, right? You have to. This is just to give you an overview of what's possible. You have to go to the documentation. You can start playing with it. If you do it enough, your fingers know, right? But fingers take. They're slow learners, right? So, it all fits. Data frame. If I'm creating a data frame, I have a dictionary. The dictionary contains, right, 2 series, and I then can use that to create a data frame from it. Why am I not getting the results? Okay, I have to make sure I run all. So data frames, we can create, there's rows and columns. The rows and columns are labeled, columns are data types, and we create them from a number of different ways. Right, so here's creating index, and here's my data frame, and it sort of prints it out really nice for me, and it's even nice when I hover over it. Right. And here I get a different index, right? I think it's having order. Just for examples of creating. So here I create a data frame, and I can index, right, column by the label of the column. And basically, what I get out is I get a series, so I can use the same. Now give me that column, which is a series. Now I can use standard series, right? And then we can use assigned values. We can just ask for give me that column, right? Now you'll be glad to know that in Pandas 1 they dropped a number of methods and data frames, some of which I use as crazy brackets to do funny things, as we saw before, right? So if you want to get individual elements out, we can use, well, right. So here I can, location is using the labels, right? And then I can start doing the slicing, right, various things. You know, give me particular elements. And then there's at and I at. The log and I log were giving us the series back, right? And then I was indexing the series. The at and I at is, you know, uniform. We're giving it bracket 1, right? So listen to the data frames, they got rid of some of the confusing. Am I using an index or am I using location by just saying you have to use at or I at. Right, so we can start asking for by location, and of course there's always 0 indexing. And then we can change the index, right, the labels, the rows and columns. So here is another inconsistency. So with series, it's index, which makes sense. But when you're doing a data frame, it really should be rows and columns. But so they did columns, but then the index with that series use. So creating a data frame. Here I'm creating a data frame with just 2 sequences. Data frames out of 2 dictionaries. You know, here is, yeah, it's like, what? Well, a list, right? That's the key. And so there's got to be an A and a B, and then there's an A and an A. So you can do some complicated things. Now we get the fun stuff, right? So here I'm creating a data frame. You know, it's various states, area, and the population. So what we're doing here is I want to create a new column called density, which is just the population divided, per area, right? So it's just data pop divided by data area, and that gives me the new, right? Series divided by series. So I can have a series, add that to the bigger column. There we go. Done. Right, so it's transposing it, right? So the columns become rows, rows become columns. It does make a lot of sense to do it right now because it's like, what? I mean, why do you draw? I mean, it doesn't make any sense to plot by a line. We can convert it to, you know, a CSV file. And so we can, pandas allow us to read all kinds of formats. CVS you're all familiar with, right? This is basically when you have comma separated, right? JSON is just a sort of HTML. F5. This is an important format for a couple reasons. One is in binary. The reason that's important is binary files are smaller than text files. So when you have large amounts of data, doing a binary is going to save less space. Also, it's hierarchical. So you can have tables and tables and tables, and you can have metadata of each table. So it's a nice compact format so we can bundle a bunch of related data together. And you can read the file without having to read the entire file at once. So there's ways of actually reading it bit by bit, or pieces of the table. So again, when you have, you know, 10 megabyte file, it's no big deal. But when you have a 10 gigabyte file, do you want to read all that once in the memory? Not if you can avoid it, right? So here, just to illustrate where I can read CSV file instead of, I mean, if I had a file, you can't see the file, then I'm going to show you. So I just create, you know, comma separated text, and then I use the string IO to convert it into a string, and then I can read it. And of course, we can give it column labels, and then you have to worry about how do I tell whether the file's got column labels or not, or row labels or not. And then of course, what's special about commas? Why can't they use other characters, right? And so yeah, create a file that contains that data we saw before, and now I can just read it in. So you know, there's a read CS, and it outputs a DataFrame for us from the CSV file. And now I can, you know, state or not, you know, are there headers or not in the various parameters. So this is our data sets. It's this famous set of data that statisticians use to illustrate various, you know, concepts. And then of course they put it online. Once they do that, then all the other data science people say, okay, we're just going to write the code to read that in. So Python has it. So there's this iris data set which talks about, well, I'm going to have to, right, it measures features of irises, and then that's the data set contains. Now we need a little bigger. And so it measures the petal size of the petal, and then the location that used to be outside the petal, which is a sepal, which thousands of stat students now know because they data set. Otherwise, who would know, right? We're not biologists. So it gives it, measurements of the petal. And so there's a URL. I can just read it in, so I can read in the data remotely, get a data frame, and then you can start doing funny, fun things with it. So again, what we're doing is get the ratio of the width versus the length and add it. Whoops. Right. Add it as a column. We can actually use lambdas as a functions to create new data sets. So here I'm creating, right, the ratio of set the width and the length, and doing the same thing with the petal ratio, and then plotting set the ratio versus the petal ratio, and oh look, there's different clumps, right? So now there's actually 3 types of them, and so now we can split the 2 groups just by using those. And of course later we can use a clustering algorithm to try and create clusters too. But graphically already you can see what the clusters are going to look like. So now you're all experts on data frames, right? In Python.